Okay, so now we're extending our Euclidean geometry, our grade 11 Euclidean geometry. So on our last class, we're doing theorem 3. If you remember theorem 3, we had 3a and 3b. 3a, it was telling you that an angle that is subtended by a diameter is a right angle, which is the angle subtended by a diameter is 90 degrees, right?
Yes.
We did a proof for it. And the second one, we said an angle, actually, if we have a chord that subtends a 90 degrees, or we have a chord that subtends a right angle, that chord should be a diameter, which means it should be passing through the center. That's what we said on the previous session. So in this session, we're going to do theorem 4a and 4b, which is the 4a and its converse. So 4b is a converse of 4a. So let's suppose we have a circle here. Can you guys see the circle?
Mm-hmm.
And we have a point maybe A here and another point B here. What is the distance along the circumference between A and B? What is this called?
Arc.
It's an arc, right?
Yes.
So there are two kinds of arc. The small one is called what?
Minor arc.
This is minor arc AB, and the bigger one is called what?
The major arc.
It's called the major arc, right?
Yes.
No problem. If I join A and B, I have a line there, right?
Yes.
What is this line called?
Chord.
So this line here is called a what?
Chord.
A chord. And this one is an arc, right?
Yes.
But to be specific, this is a minor arc, which is the distance along the circumference between 2 points is called an arc.
Mm-hmm.
And this one from here all the way there is also what? An arc as well. But the difference is the bigger one. So it's a major,
Arc.
it's a major arc. Is everyone happy?
Mm-hmm.
Okay. So what is the name given to the area between an arc and a chord? So the area that is enclosed, or the area that is bounded, or the area that is between a chord and an arc is called a what?
A segment.
Is a segment. So this is a segment here. So, but because this is the smaller segment, you see that your arc, your chord divides your segment into two segments.
Yes.
This segment here and that segment over there.
Yes.
This is a smaller segment, so we'll call it a what?
Minor segment.
A minor segment. And this one here is
A major
it's a segment as well, this entire area here. But it's a major segment. Major. Is everyone happy so far?
Yes.
Okay. So now I'll draw another circle down here. King of circles. Then let's say now we have C here, or maybe we have D there. I'm going to draw these two here. So you can see here you have a major segment. Here you have what?
Minor segment.
A minor segment. So if your chord or an arc subtends an angle, if a chord or an arc subtends an angle, there are two positions, there are two options or two areas it can subtend on. It can either subtend on the major segment or on the minor segment. Are you guys following?
Yes.
So if you look at this angle here, let's say this is angle A here. You can see angle A is subtended by your chord CD or your minor arc CD. Where is it subtended? On the minor segment or the major segment?
The major segment.
So it is subtended on this part here, which is the angle is inside the major segment. Are you following? This is your major segment. Can you see it?
Yes.
So this angle A is subtended inside the major segment. So it is inside the major segment. There it is.
Okay.
Which is the area in which it is located is in the major segment. So if we were to subtend maybe another angle there, let's call it maybe B. So you can see it's here, right?
Yes.
So if you look at it, it's subtended on what? On the major or on the minor segment?
On the major.
On the major segment, because it's subtended on the bigger segment. If maybe CD maybe were to subtend another angle here, this is angle E. So here is angle E. Where is it sitting? Is it sitting on the minor segment or major segment?
Minor segment.
It's sitting on the minor segment. So, because this is the smaller segment, it's a minor segment. So, are you clear what a segment is?
Yes.
But I think I did explain it on the first classes when I introduced this thing. So, now, what I want to talk about in this class or in this session, I want to talk about the angles that are subtended in segments. Are you with me?
Yes.
Are you guys following?
Yes.
I want to talk about the angles that are subtended in segments. For example, what I'm going to be teaching mostly, or maybe importantly, is that if you have your A and B, and both of them are subtended by the same chord or same arc, A and B are both subtended on the same segment.
Yes.
And that segment is the major segment because it's the bigger segment. Are you with me? So you have CD as your chord, subtending angle A and angle B.
Yes.
A and B are angles in the same segment. They are subtended by the same chord, which is CD. So, and CD is subtending them on the upper segment, which is the major segment. So A and B are the angles that are subtended in the same segment. Are you guys following?
Yes.
So in that case, what I want to prove for you is that angles that are subtended by the same arc or the same chord in the same segment, they should be equal. They should be the same. That's what I'm going to prove in this session. And the converse as well is true, which is what we're going to get to. Does it make sense?
Yes.
So the point is, you can look at them. These angles are in the same segment because they're in the upper portion that is enclosed by your major arc and your chord. Because you can see A and B, they are enclosed by this major arc and the chord CD. So these two are angles in the same segment. So do you guys understand?
Yes.
So the theorem that I'm going to prove is that if you see two angles that are subtended in the same segment by the same arc or same chord, they should be equal. Do you guys understand? So we're going to prove that in the case like this, A and B should be the same. Do you see that?
Yes.
And if you're looking at it, do you see what is this length AB called?
It's an arc.
It's an arc. So you can see that, you can also argue that your A and B are subtending D and subtending C.
A and B.
AB, this chord, this arc AB,
Yes.
it subtends angle D
Yes.
and subtends angle C.
Yes.
So which means this area, if you were to join maybe, let's imagine that you join them. You have some sort of a chord joining them. So this is a segment as well, if you look at it. This is a segment.
Yes.
Do you understand?
Yes.
So C and D are angles in the same segment as well. Do you agree?
C and D.
Yes. They are angles in the same segment because they are subtended by a chord arc AB.
Okay.
Because look, your arc AB subtends C
Yes.
and subtends D.
Yes.
And if you were to join a chord somewhere here, you can clearly see, let's say we join a chord here. Here is a segment. And then there is a chord.
Oh, okay.
So C and D are angles in the same segment. So they should also be equal.
Okay.
So what I want to prove here is that angles in the same segment should be equal, which is the angles that are subtended by the same chord are equal. Are you with me?
Mm-hmm.
So when you say angles in the same segment, the segment is the same if only if this is sitting in the same area, in the same position. Are you with me?
Yes.
When you say angles in the same segment, which is that's subtended by the same stuff, because if the moment AB moves and become here, you're not looking at the same segment now. Those are two different segments.
If what?
If your AB is somewhere maybe here, this segment is not the same as that. They may be equal, but they're not the same. Are you guys following? So I'm going to clean this and write theorem 3, and then we are going to prove theorem 3a. So let's clean the board. Okay. So now we're going to look at theorem 4. Theorem 4 states as follows. Reads as follows. They are saying angles subtended by an arc or a chord in the same segment are equal. Are you with me?
Mm-hmm.
They are saying angles subtended by an arc or a chord in the same segment are equal. So those angles are subtended by the same arc or the same chord in the same segment. They should be equal. Look at this. Here is AB. Can you see AB here?
Yes.
It's the arc AB.
Yes.
Or you can think maybe as an imaginary chord AB.
Yes.
So if your arc AB subtends angle D and angle C, then these two angles should be equal. Are you guys following?
Yes.
It doesn't matter, no matter how many angles are there, even if they're subtended here, all those angles up there will be the same. Are you guys following me?
Yes.
So in this case, D and C are in the same segment because they're on this segment that is between this major arc and your imaginary chord there. Are you guys following?
Yes.
So what I'm saying that angles in the same segment are equal, which means I'm saying angle C is equal to angle D. And if you're looking at angle B and angle A subtended by your arc DC, what I'm saying, these two angles are equal because they are both subtended by your same arc DC
Yes.
on the same segment, which is the lower segment,
Yes.
which is the major segment, if you're looking from that side.
Yes.
Are you with me?
Yes.
So I'm not going to claim that I'm not going to prove that both of these are equal and both of those are equal because the proof is exactly the same.
Yes.
I'm just going to prove one way. It works for all of them. Are you with me?
Mm-hmm.
So what are we trying to prove? What is our claim? What is it that we're trying to prove?
We're trying to prove that
The angles in the same segment are equal.
What angles are those?
Angle D is equal
Angle
to
D is equal to
angle C.
angle C. This is our claim. So this is what we want to prove. So let's go on and prove it. So we say proof. Are you with me? I'm going to construct some stuff. So let's say construction. Right? So let's say maybe let O be what? Be the circle center. So O is the center of our circle. Are you with me?
Yes.
So let's say maybe our center is here. So can you guys see it?
Yes.
Are you with me?
Yes.
So after that, I'm going to join OA and OB. Are you guys following?
Yes.
I'm going to join what? OA and OB. So let's write it down and say, okay, we'll start construction. Join OA and
Okay.
OB. So if you join it, looks something like this. Right? And there we go. Are you guys following?
Yes.
So maybe you can say maybe this is O1 here, if you want. Are you guys with me? So we know from the second theorem that the angle O1 angle at the center is twice the angle at the circumference. Right?
Yes.
Angle at the center is twice the angle at the circumference. So which means by theorem 2, it's okay. Angle at the center, which is O1, is equal to 2 times what?
C.
Angle C. Why? Theorem 2, which is angle at center, is equal to 2 times angle at circumference. Are you with me? We can use the same theorem and say that the same O1, which is the same O1, is called twice angle D, because this is the angle at the circumference.
Yes.
So 2 times angle D. Reason is the same as above. Angle at center is equal to 2 times angle at the circumference. Is everyone happy? But look, O1 is equal to O1. Right?
Yes.
So if the left-hand sides of this equation are equal, so are the right-hand sides. Are you guys following?
Yes.
If you're saying O1 is equal to O1, so which means you're saying the left-hand sides of these two equations are equal. So which means the right-hand sides as well, because if you're saying this is equal to this, and this is equal to this, and this is equal to this, these two should also be equal. Right? So which means your twice angle C is equal to 2 times angle D. Divide by 2, divide by 2. You get that your angle C is equal to your angle D. So the angles in the same segment are equal. There they are. We prove them. If you wanted to prove these ones down here, you'd have to join this and join that, the proof will exactly be the same. Are you guys with me? And if you want to use this theorem, your reason for usage, what do you say? Your reason for usage will be angle in same segment. There is it. If you're saying to me angle C is called angle D, there is a reason. Those are angles in the same segment. If you're saying angle B is called angle A, same reason. These are angles in the same segment. It should be angles because there's many of them, 2 or more. These are equal because these are angles in the same segment. Are you with me?
Yes.
Okay. Then now, this is theorem 1 for A. We're going to do examples, of course, and you guys are going to do the problems. Then now, the converse is also true as well, which is theorem for B. The converse is also the same. What are they saying in the converse? They're saying, if you have a line segment like this, let's say the line segment is AB here. Can you see? There's a line segment. A line segment is a line that starts, you know where it starts and ends. You know the starting point and the end points. It starts there and there. If you can tell me where it starts and where it ends, then you have a line segment. Do you understand?
Yes.
Do you guys understand?
Yes.
As opposed to maybe a line that just continue indefinitely. So this is a line segment AB. So the converse is, if you see your line segment AB and your line segment subtends, maybe let's say it does subtends at angle what? Angle C. And subtends what? Angle D. Are you guys following?
Yes.
Your line segment AB, it subtends 2 angles, angle C and angle D. Did I say AB is a chord? No, it's just a line. There's no circle here. So, if you see a line segment, this, which is AB, or in this case, you see, I had what? I said an arc or a chord, but you don't see the chord. Do you understand?
Yes.
So sometimes, it's either you can have, if you see a line segment, AB, or maybe 2 points, can just maybe, there's no line, just 2 points. Because if there's a line segment, which is you have a chord there, it is just 2 points, which is you're looking at an arc here.
Can you please stop it?
I'm saying, in this case, I said an arc or a chord, but do you see a chord here?
No.
I didn't write it. I didn't need to, because you can see the point, right? So in this case, I'm saying if I'm talking about a line segment, it's an equivalent of me, or the same as, or similar to me talking about a chord there. But if I'm talking about an arc here, do you see, is there, so if I'm talking about this arc here, it's more, it's me about me talking about this point, or just 2 points A and B, no line in between.
Okay.
You don't understand?
I do.
You do understand?
Yes.
So in this case, because look, these two, it's an arc here, right?
Yes.
But you have to think of a segment as if there's a chord here.
Yes.
Do you understand?
Yes.
But here, this line segment subtends, or it can be just 2 points subtending. So you can just have 2 points subtending. That would be equivalent having an arc. If you have a line segment, it's equivalent of you having a chord. Do you understand that part?
Yes.
See?
Yes.
Okay. In that case, if you see a line segment or 2 points, right, that are subtending equal angles, let's say up to these 2 angles are equal. And those 2 angles that are subtended, they are subtended on the same side, either above or below, both of them, those 2 equal angles. Or maybe on the left of the line or the right of the line. If maybe this line, if AB was like this, it's either they subtend this side or that side, or down this side or the other way. So the point is, the subtended angles must lie on the same side of the subtending line segment or points. Did you get that?
Yes.
The subtended angles, they must be on the same side of the subtending arc, also of the subtending line segment or subtending 2 points. They are saying that now, if you see 2 line segments So if you see a line segment that subtend two equal angles on the same side of that line segment, then all these 4 points, which is the end points of your line segment, and your 2 other points, all those 4 points will be concyclic, which means they lie on the same circle, which means there is a circle that can join all of them nicely. So which means you can be able to draw a circle that passes through all of them, something like this. Do you understand? So if you see a line segment that's obtained 2 angles on the same side, all the points lie on the same line. They are called concyclic, which is all of these 4 points or more maybe. They lie on the same line, which means you should be able to draw a line that will join all of those points over there. That's the converse of it. That's for B. Do you guys understand what I'm trying to say? I'm going to prove for B, but you don't have to know the proof of B. Don't bother with it. But I just want you to know how to use it. If I'm saying that, prove that these 4 points are concyclic, which is they lie on the same line, I want you to know that you should show, if you have something like this, I want you to be able to show that a line segment subtends 2 points on the same side, 2 equal angles on the same side, or these 2 points, maybe A and B, are subtending 2 equal angles on the same side. Then if you do that, you will have proved to me that all those points are concyclic, they lie on the same circle. Do you guys understand?
Yes.
So I'm going to clean the board, I'm going to write theorem 4a, and I'm going to prove it. So let's go. Okay, so now I've written it here. So let's read it and then talk about it more and try to prove it. So that's saying if a line segment or 2 points, right, subtends equal angles on the same side of the line segment, right?
Yes.
Then the points are concyclic. So what they're saying, you have a line segment AB here, and this subtends equal angles. Let's say these 2 angles are equal here. Let's say this is angle, and this angle is X, and this angle here is X. Do you guys see? So we have a line segment that subtends these equal angles, angle D and angle what. They are on the same side of the line segment. In this case, they are both above the line segment. That's what on the same side mean. It means it's either they're above or below. If it was vertical, if the line segment was vertical, they're on the left or on the right of the line segment. Are you guys following? So they're saying now, then all the points are concyclic. So if you have line segment AB that subtends 2 equal angles on the same side, right? Then all the points in which the angles are subtended, including the end points of the line segment, will be concyclic. Which means, what does it mean to be concyclic? They lie on the same circle, which means they all lie on the circumference of one circle, which means there is a circle out there that we can be able to draw so that it joins all of those points. Are you guys following?
Yes.
When we're saying the points are concyclic, which means there exists a circle that joins all of those points. We can find a circle that will be good, big enough to join all of them. So that maybe this will not be this will not look good. Maybe a circle will be like this. Something like this. But you can make it a solid. The point is that you will be able to draw a circle that joins all of them. So what we're trying to prove that the points are concyclic. They lie on the same circle. Are you with me? So our claim, points are in this case A, B, C, and D are what? Are concyclic. Our claims are A, B, C, and D are concyclic. Cyclic. They lie on the same circle. Or there exists a circle that joins all of them. Are you guys with me? So in that case, how do we prove this? To prove this, we don't have enough geometry to be able to prove this, to be honest. Are you with me? So, for example, in most of the problems that I've used from theorem 1, theorem 2, and theorem 3, and theorem 4, the one that we just did, we use the theorems above to prove the next theorem. Are you with me? So this is a different case. So we don't have enough geometry to prove this because the theorem 1, 2, and 3, or the theorems that we know are not enough to prove this. Are you guys following? So what we're going to do, we're going to use another kind of proof called the proof by contradiction. Are you guys following?
Yes.
So the the idea behind proof by contradiction, you guys might not know it. I understand why, because you don't do it maybe, or you don't do a lot of it at your level. The proof by contradiction is the idea that if you're saying, okay, if you say, okay, let's say suppose that we have statement A, and statement B. You understand? If you're saying that if A happens, then I'll do B. Do you understand? If A happens, then I'll do B. Are you with me?
Yes.
They're saying now, this statement is equivalent, which is more or less the same, right? This is more or less the same. This statement, you're saying if A happens, then I'm going to do B, right? They're saying that this statement is more or less the same or equivalent or logically equivalent to saying that if A happens, so you see A happens, right? And then not B. In this case, they're saying, you said if A happens, then I'm going to do B, right? This statement is the same as saying A happens and I'm not doing B. Do you understand? And after not doing B, you run into problems. So, say problems. For example, I'll make an easy example. Let's say, if Kaizer Chiefs wins today, I'm going to drink. Do you understand? I'm saying, Kaizer Chiefs winning, I'm going to drink. So A is if Kaizer Chiefs win, right? The B represents I'm going to drink tonight. Do you understand?
Yes.
So I'm saying in this case, if Kaizer Chiefs win, I'm going to drink tonight. Do you understand?
Yes.
And then the Kaizer Chiefs wins, and I do not drink. Was I telling the truth or lying?
Lying.
You can say I lied because I said if A was going to B, if A was going to happen, B, I was going to do B. And A did happen. B was not an option anymore. I was not doing B. Do you guys understand?
Yes.
So in that case, instead, after Kaizer Chiefs won, I didn't do B. And now, after not doing B, I get some problems down the line. So in this case of maths, we're saying that if a line segment subtends two equal angles on the same side, right? Then all the points will be concyclic, which is the end points of your line segment, and the two other points, they all lie on the same line. Do you understand?
Yes.
That will be my B. So now, I'm going to assume that this thing is false. Do you understand? I'm going to assume that the entire statement is false. What does it mean the statement is false? The statement is false only if I don't do what I said I was going to do. Because I said if Kaizer Chiefs won, I'm going to drink. And Kaizer Chiefs won and I didn't drink. I lied there. Do you understand?
Yes.
So what I'm going to do, I'm going to falsify the statement. Because this A happening and B not happening, it's me being untruthful. It's me being false. It's making the statement false. Do you understand? And then now, we'll assume that this statement is false, and then we're going to do some maths with this false assumption. We're going to get into trouble, right? So now, as making the statement false and running into problem is equal to the statement, is equal to the original statement. So which means we should assume that this statement is false and do the maths that we know and run into problems. If we run into problems, which means our assumption was false, therefore the original statement was true. It's called mathematical logic. I don't expect you to know it, but what I'm trying to say to you is that we're going to assume that this statement is false. And then we're going to work with that statement, whatever information that we have. the problems that are going to happen because we assume that the statement is false to begin with. Which means the reason we are running into problems is because of that false statement. Therefore, the original statement, we're not supposed to make it false. It was true. And you will be done with the proof. Does it make sense? Okay. So in this case, what we're going to do now, we're going to do exactly this. What we're going to do, this is our proof now, right? Proof. We're going to assume that theorem 4b is false. If the theorem is false, the part that will be false is the one after then, the one that was said was going to happen. Because remember, I said if Kaiser Chiefs win, I'm going to drink. I'm only going to be lying if Kaiser Chiefs win and I don't drink. Do you understand?
Yes.
Whatever happens, if Kaiser Chiefs doesn't win, you can't say I was lying because my drinkingness was dependent on Kaiser Chiefs winning. Do you understand?
Yes.
So now, what we're going to do is going to assume that this statement is false. And then do the maths afterwards. So let's assume theorem what? 4b is what? Is false. Do you understand? We're assuming that theorem 4b is false. So what does it mean for theorem 4b to be false? For theorem 4b to be false, which means we have a line segment that joins line segments or 2 points that subtend equal angles on the same side, right? Same side of the line segment. But those points are not concyclic. Do you understand?
Yes.
So that part not concyclic is you not drinking now. It's me not drinking after Kaiser Chiefs won. The first part did happen, but I didn't drink afterwards. So it's more like when I get paid on the 25th, I'm going to send you money, right?
Mm-hmm.
I'm only going to be lying if I don't send the money when I get paid on the 25th. Do you guys understand? If I don't get paid on the 25th, how can I be lying? You can't be holding me liable for that. For that matter, I was truthful. I was being truthful. So in this case, we assume that the theorem 4b is false. The theorem 4b is false, which means, let's write down what it means. It means there is a what? A line segment that subtends equal sides on the, equal angles. Subtends, we have a line segment. Line segment or points most, ne? We have a line segment or points that subtends equal angles on the same side. But the points are what? Are not concyclic. What does concyclic mean? It means lie on the same circle, which is they lie on the same circumference. Do you understand?
Yes.
So, if I'm saying they're not concyclic, what does it mean?
Means that they are not lying.
Which is, the points do not all lie on the same circumference.
Yes.
How many points? Can be 1 point not there, can be 2 points, can be 3 points not on that line. All of them will not be concyclic. Or maybe all of them will not lie on that line for that matter. Which is there's no circle that joins all points. Do you understand?
Yes.
So, in this case, we're saying that the points are not concyclic. So which means, if we're saying that they're not concyclic, we can say at least 1 point is not on the line. It's not on the circumference. Do you guys understand?
Yes.
1 point is not what?
On
On the circumference. So, which means we have this sort of circle like this here. Can you see this circle here?
Yes.
And give your AB. And then that angle D, that is angle D subtended here. Can you see angle D?
Yes.
And you said it was X most, right? Are you with me? But the angle C, this angle here, is outside. So these points are not concyclic. Because they do not all lie on the circle.
Yes.
To be concyclic, they must all lie on the circumference of the circle. So this angle here, maybe it's also X. Because we said we have a line segment. We said that there is a line segment that subtends two equal angles on the same side. Now here's a line segment and subtends those two equal angles on the same side. But now the problem is that all these points are not concyclic, which means they do not all lie on the circumference. Do you understand?
Yes.
Do you understand?
Yes.
So this circle is the only circle that joins maybe all these three, but that one lies outside. Are you with me?
Yes.
Fine. What I'm going to do here, I'm going to construction. Are you with me?
Yes.
On my construction, I'm going to join maybe BE. Are you with me? But where is E? E is this point where your AC cuts the circle. Do you see it?
Yes.
Let's call it what? Angle E. I'll write it in red so that you see that is part of my construction. Can you see angle E?
Yes.
And then now, let's join these two. Are you with me?
Yes.
So now let's try to prove it. So, when I'm trying to prove this, let's say maybe we have B1, B2, and B3, right? And this E1 and E2 maybe. Are you guys happy?
Yes.
Are you guys happy?
Yes.
Okay. Then, if you're looking at this, you can say, if you're looking at this, your angle D is equal to angle C and they're both X. What is the reason for this? This was given information. It's what you had. You said there is a line segment that subtends two equal angles on the same side.
Yes.
And those line segments are D and C.
Yes.
So this is given information. Are you with me?
Yes.
See what? I want to say angle C, angle D, is this angle here, is called angle E, E1. And they're both X. Why would I say that?
Okay. Angle D is equal to angle E
E1.
because they are subtended about the same arc or chord
Okay. The reason for that is angles in the same segment.
or angle the same segment.
Yes, because they're in the same segment.
Okay.
So angles in same
Segment.
segment. Those two are equal. Are you guys following?
Yes.
No problem. So at the same time, which is you're saying E1 is equal to D, right?
Yes.
So E1 is equal to D over there. But E1, if you look at E1, looks like E1 is an exterior angle of this triangle. Do you guys agree?
Yes.
E1 is an exterior angle of this triangle.
Yes.
So which means your E1 is equal to what?
Angle C
Angle C
and angle B3.
plus angle B3. Say what? Exterior angle of the triangle. Are you guys following?
Yes.
But look now, E1, you said is equal to what?
Is equal to X.
E1 is equal to, sorry?
X.
So, which means we have X here
Yes.
is equal to angle C. Angle C is equal to what?
X.
It's equal to X plus B3, right?
Yes.
Therefore, your B3 is equal to what?
To X. No, sorry.
Because B3 is equal to 0, these ones go away.
Yes.
But look at B3. B3 is an angle of a triangle, right? B3 here is it? It's the angle of this triangle.
Yes.
Is it possible to have a triangle with an angle 0?
No.
This is impossible. So this is the problem that I was talking about. You assume the statement is false and do the normal maths that you know, right?
Yes.
Once you run into problems, they are coming from the fact that you make a wrong statement. This is the problem, not the actual.
Okay.
Which means this is wrong, that is right, and we're done. Are you guys following?
Yes.
So this is a contradiction, because you can't have an angle. This contradicts with the knowledge that angle of a triangle, it can't be 0. Because if this is 0, which means this angle is not there. Do you understand?
Yes.
If this is 0, which is there's no angle there.
Yes.
Which is if there's no angle there, this thing is sitting over there. Which is it falls on the what? Where C, which is your angle C is equal to angle E. They're just sitting, they're both over each other, which is this point is over there. Because if this is 0, which is this is sitting over there. Do you understand? So in that case, to close this, we said this is impossible. Therefore, Therefore, our assumption, which is that our assumption was what? Was false. Which this is wrong. Therefore, statement of theorem 4b is what? Is true. Should have proved that thing. We're done here. This is called proof by contradiction. Do you guys understand?
Yes.
Fine. So, what I want you to take, I don't need you to know the proof, but what I want you to take away from this is that if you see a line segment joining, if a line segment or 2 points subtends equal angles on the same side, all those points are contracted, which is they lie on the same circle. Are you with me? And also, if you have a circle and you have a chord subtending 2 angles on the same segment, then those angles should be equal.
Okay.
Are you guys following?
Yes.
Then now what I'll do from here, I will tell you now the outcomes of this theorem, of theorem 4. Are you with me? Yes. I'm going to show you the outcomes of theorem 4. That's what I'm going to do here. The outcomes of theorem 4. So I'm going to clean the board, and then from theorem 4, you're going to get a lot of nice results that I think you need. So let's go. So now, we're going to look at outcomes or results or consequences of theorem 4. Right?
Yeah.
Let's say you have a circle here. Can you see the circle here?
Yes.
There's the center here. Let's say you have a chord. You see this chord?
Yes.
And this chord over here. Let's say these chords are equal. Are you with me?
Yes.
These chords are what?
Are equal.
Are equal. So, if the chords are equal, they're called congruent, right?
Yes.
The same way they are identical. So you have congruent chords. Fine. So look, think about this. I want to look at this for a second. If this is equal, if these two are equal, I would argue that they are sitting exactly, actually, they are cutting this circle in 2 equal parts. Okay, let me just phrase that. You see, this chord cuts this circle into 2 parts, the major segment and that minor segment over there.
Yes.
Are you with me?
Yes.
This chord is equal to this one, right?
Yes.
Which means this one as well will sit exactly the same way as that one. It will also cut this, there will be a major segment and a minor segment. Because these 2 chords are equal, they are joining the same anywhere. The major segment, which is this part, all of it, it should be the same as the major segment of all of that. This chord and this chord, these 2 chords are congruent. Are congruent. Right?
Yes.
So, this chord, this one, split your circle into 2 parts, into 2 segments. This major segment and the minor segment. This one does the same thing, splits the major segment and the minor segment. I'm saying now, the major segment, if you look at the major segment of this, it will be this chord and the major arc. Do you understand?
Major segment.
Yes, major segment of this chord.
Okay.
The major segment of the chord is this one here.
Okay.
This area here, all of it, including the one that is occupied by this guy. So, the major segment of this chord is bounded or is enclosed by the chord and the major arc here.
Okay.
Do you agree?
Yes.
I'm saying to you, if these chords are are congruent, which is they are identical, they are equal, they cut this circle exactly the same way.
Yes.
Which means the segment, the major segment of this chord here will be equal to the major segment of that, but they will have different orientations. Do you agree?
Mm-hmm.
I'm saying this major segment here in size is equal to this major segment here in size, but they're just placed in different ways. So those segments are congruent. Do you understand? Those major segments, they are congruent, including the minor segment. The minor segments are also congruent. So if you have congruent chords subtending angles in congruent segments, they should be the same. They should subtend exactly the same angles or equal angles. So because you have equal chords in the same circle, subtending angles at the circumference maybe, those angles should be the same. Do you understand, Z? See, we understand?
Yes.
I'm saying equal chords. In equal chords subtend equal angles. That's what I'm saying.
Okay.
At the center or the circumference.
Okay.
So, point is, if this subtends an angle here, and we call it maybe x, and this equal chord also subtend an angle here, that angle should also be x. So equal chords subtend equal angles at the circumference.
At the circumference.
At the center. At the center.
Okay.
At the center.
They
Right?
should be on the center.
Yeah?
They should be on the center only.
No, not only.
Okay.
But for now, I'm just saying at the center.
Okay.
In a similar way, if this chord of yours subtend angles at the circumference, let's say you subtend that angle there, and that angle there is y, can you see it?
Yes.
And it subtends another angle there. That angle over there should also be y.
Okay.
Because it's more like you are having, because look, if you were to move this chord all the way here, it will fit exactly over this one.
Yes.
And you would have exactly identical, it would be more like angles in the same segment. That's why I'm saying it's an outcome of theorem 4. Do you understand, Z? If you take this and drag it, and it will overlie exactly to this one, you'll be saying that these are angles in the same segment.
Yes.
But just that they have different orientation. This is some sort of congruence of line of major segments. I'm not saying there is congruent, but it's some sort of thing about congruence, but of segments.
Okay.
So in a similar way, so now I'm going to write it now and say for this thing, equal chords, equal chords, subtend equal what? Angles at the center or circumference of the circle. Are you with me?
Yes.
So equal chords subtend equal angles in the circumference or the center of the circle. If you want to be funny, you can say congruent chords subtend congruent angles at the center or circumference. We're being fancy now. Congruent chords, which is these are equal chords, subtend congruent angles at where? At center or circumference of the circle. Are you guys following?
Yes.
Are you following, Z? Now, go to the next one. On the next one, let's suppose that we have a situation like this. Are you with me?
Yes.
Then, you have this chord here. Maybe that chord over there doesn't look like very much like a circle. So let's say this chord subtend an angle there, right?
Yes.
There is an angle, and this chord subtend another angle there. Are you with me?
Yes.
And this angle here is y, and that angle is y. So those chords subtend equal angles. Are you with me? Those two chords, they subtend the equal angle y. Are you with me? Are you guys following? Okay. So if you see two chords subtending equal angles, those two chords are also equal. I'm not sure if you understand what I'm saying. So angles, chords that subtend equal angles, they should be equal. I'm not sure if you guys are following. Can it be at the center or can it be at the circumference? I'm not sure if you understand what I'm trying to say. So, chords that subtend equal angles, or equal angles are subtended by equal chords. Does that sound nicer?
Equal angles.
Equal angles are subtended by equal chords.
Oh, okay, yes.
So, this is outcome number 1, right? This is outcome number 2. Let's go to outcome number. So I'll say now, equal angles are what? Are subtended by equal chords. Because if you think about it the same way we thought about this, right? We're saying these two angles are equal. Are you with me? They're in the same circle. Both of these angles, this is the one circle, right? So if they're equal, you would like to think of them, they're subtended in the same segment. Or maybe in congruent segments. In identical segments. And to achieve that, these two have to be equal.
Like what?
I'm saying, you see two angles, right?
Yes.
This is one circle. Are you with me?
Yes.
This is one circle. So, because this is a single circle. So what I'm saying is, if both of these two angles are equal, you would think it would be nice if they were subtended in the same segment.
Okay.
But they're not the same segment. Chances are, or what I'm saying is, the segments that they are subtended to are equal. And those segments will be equal if these two are equal. And if I say, okay, so equal angles are subtended by equal chords. Are you guys following?
Yes.
Can be the center, can be the circumference. So do you want me to write it by congruence? Or are you happy with it? You don't want congruent stuff? Yeah?
Okay.
Okay. Fine, let's go to number 3. Let's go to to outcome number 3. If we have two circles here, can you see these two circles? They don't look very equal. Let's say maybe the radius of this one is R, and the radius of this one is R as well. They are equal. Do you understand?
Yes.
So, the two circles, A and B, are congruent if they have the same radius. So these are congruent circles. Are you with me?
Yes.
Are you with me?
Yes.
These circles are congruent. Circles are only congruent if the radii are the same. If the radii of these two circles are the same, then those two circles are congruent. For example, say the radius is R and the radius is R. So which means these two circles are congruent. Of course, they're not drawn to scale, but the information that is on the diagram is enough for you to say that those two circles are congruent. So now on these circles of yours, let's suppose that you have a chord here and you have another chord, maybe this way. Are you with me? And this chord is equal to this chord here. If you think about these two guys, if you think about these two circles, it's exactly the same circle. Because they are congruent, they are identical. Circles are identical if they have the same radii. Are you with me? So, this circle, you can overlay exactly over this one. Do you agree?
Yes.
Because they're equal. They are congruent. Are you with me?
Yes.
In a similar way, if I can align this on top of this, which means even these two, they can also perfectly fit over each other. Do you understand what I'm trying to say? If you're looking at this and this, these circles are the same and these two are equal, which is this circle can fit exactly over this one if they are congruent. And this chord is also congruent to this one, which means you can also even move it so that it fits exactly, they overlay perfectly. Do you understand? So in that case, if now these two chords are equal in equal circles, these chords will subtend exactly equal angles, which is angle x, and even this one, it will subtend angle x. Because if you think about it, you're looking exactly in the same circle. Because this you can overlay this circle on top of this one, and even this chord here, you can overlay it over this one. And if you do that, this angle, those are the angle in the same segment. Do you want me to repeat that?
No.
Honestly?
Yeah.
You don't want me to repeat it. So in this case, what I'm trying to say is that congruent chords in congruent circles subtend congruent angles. Do you understand?
Yes.
Congruent chords, which is equal chords, in equal circles, will subtend equal angles. Because they're exactly the same. So, what I'm trying to say here, I'm saying congruent chords, which is equal chords, in congruent circles, which is equal circles, subtend congruent angles. That's what I'm trying to say. Any questions for me? So, I expect you to know these outcomes because they might help you. In fact, you might need them or you need them. So what I've spoken about first theorem 4a, angles in the same segment are equal. Theorem 4b, angles equal 2 points or a line segment, or 2 points or n points of a line segment that are subtend equal angles on the same side they will all be concyclic. Are you with me? And then I said that equal chords subtend equal angles at the circumference or center of a circle. And then I said that equal angles are subtended by equal chords. Here I'm saying now congruent chords in congruent circles subtend congruent angles. Then I'm going to do an example and I'll be done. Any questions? Please, I'm begging for questions. Okay. In that case, I'm going to clean the board and we do examples and we will be out of here. So let's go. But given, this is first example, right? Given A, B, C, and D are 4 points on the circumference of the circle. Do you see A, B, C, and D?
Yes.
There are 4 points in the circumference of the circle. They are concyclic. Do you understand? They lie on the circumference of the circle. No problem. They are saying you are given chords AC and BD that intersect at K. AC and BD. AC and BD are chords and they intersect at that point K over there. So, is K the center?
No.
No, it's just the intersection of those chords. No one said it's the center, so it's not. Not everything in the center that looks like it's in the center is the center. No problem.
Meaning that chord BD, like BD, is exactly like 1 into 2 equal part.
You don't understand.
They're not equal.
Okay.
We can't say they're equal because
Okay.
They are not radius.
we-
UBK and KD are not the radius.
so if KABD was a diameter,
Okay. Okay.
then we would say it splits it into 2 half equal parts. But it splits it into 2 parts now. If they're equal or not, we don't know.
Okay.
And it's safe to say they are not, unless we're told that K is the center or BD is a diameter.
Okay.
Right? They are saying that angle A1 is equal to 21 degrees. A1 is 21 degrees, should be 21 degrees. Oh, the angles are okay, but the numbering is wrong. So, this is 44, this is A1, and this is A2. Everyone happy?
Yes.
That's saying angle A1 is 21 degrees, can you see it?
Yes.
They're saying angle A2 is equal to 44 degrees, can you see it?
Yes.
They're saying angle B is equal to 63 degrees. So they want us to find D1. Where is D1? D1 is this angle here. Subtended by what? D1 is subtended by AB. Can you see?
Yes.
D1 is subtended by AB.
AB.
Is that correct?
Yes.
Is it the only angle that is subtended by AB?
No, also by AC.
Sorry?
Oh, D1, right?
Yeah.
Not just D.
Oh, they want us to find D1, which is this angle over here.
It's subtended by AB.
Subtended AB.
Yes.
And it's the only angle that is subtended by AB. Do you see?
Yes.
No.
AB only subtends this angle here.
AB.
Yes, the chord AB.
That chord AB.
Yes, only subtends this angle here.
D1.
D1. So is there anything else?
No.
No. So we don't have much options around what is subtending, but we can do it in your way.
Can I ask? You said angle D1 is subtended by
AB. Yes.
What about angle K1?
Yeah, subtended by AB as well, but
But
what is it? We don't even know what it is. Even if we knew what we're going to do with it, because it's not the center.
okay. Oh, okay, I get it.
So even if we knew what it was not very helpful. So we can look it in your way, which I think you'll love very much. This is a triangle. You know, you love triangles. So this is a triangle over here.
Yes.
So this is an angle of a triangle.
Yes.
So we can say at A, in triangle, what?
AB.
ABD. We'll say angle A plus angle B plus angle D is equal to 180 degrees. What is the reason? Sum of angles in a triangle. Are you with me?
Yes.
And then in that case, A is made of A1 plus A2. Are you following?
Yes.
And the angle B is just made of angle B. Angle D is D1, right? Equal to 180 degrees. Are you guys following? The A1 substitute is 21 plus A2, which is 44, plus B, which is 63, plus D1, which is D1. It's called 180 degrees. What is the sum of these angles?
Which angle?
These angles. 21, 44, and 63.
128.
So 128 plus what? Plus D1 is called 180 degrees. Therefore, your D1 is called 180 minus 128, which is what?
52.
Which is 52 degrees. Okay, that D1 is called 52 degrees. Let's go and put that angle D1 over there. It's called what? 52 degrees. Everyone happy? Next, they want us to find what? They want us to find D2. Where is D2? D2 is this angle here. What is it subtended by? Follow it. Subtended by what?
By arc BC.
By arc BC. Is it the only angle that is D2? Is it the only angle that is subtended by the arc?
No.
Also K. That.
No.
Oh, sorry. A. Sorry.
A is also subtended by BC.
Yes.
So angle A2 and angle D2 are angles in the same segment.
Yes.
So they should be equal.
Yes.
So what we're going to say, what's okay? For B, we're going to say D2 is equal to what? D2 is equal to
A2.
A2. And your A2 is equal to what?
44.
44 degrees. Reason will be angles in same segment. So that means that angle over there is what?
44.
It's 44. Everyone happy?
Yes.
No problem. Then we're done with D1, done with D2. We're finding angle C. Where is C?
Down there.
Down there.
Yes.
Subtended by what?
What? A.
Subtended by
AD.
AD. Is it the only angle that is subtended by AD?
Also B.
Angle B is also subtended by AD. Which is these two angles are angles in the same segment.
Yes.
So angle C, so doing C. Angle C is equal to what?
Angle B.
It's equal to angle B, and they're both equal to
63.
63 degrees. Why?
Angle in the same segment.
Angles in same segment. So you can put it. It's okay. There's 63 here. Everything that I find, I put it in the diagram. So we're done with this one here. Sorry?
Okay, let's move to K2.
K2, where is K2? K2 is this angle over here. What is this angle over here?
You want the answer?
Okay. An angle that is sitting where K2 is, what is it called? This angle here. What is K2 to this triangle?
It's an exterior angle.
What is K2 to this triangle?
It's an exterior
It's an exterior angle. So you're looking for the exterior angle of the triangle. So you know to find an exterior angle of the triangle. So your K2, K2 is equal to what? It depends which triangle you're looking at, right?
Yes.
Let's be specific. Where's the pen? Where is it? Oh. So let's tell them which triangle we'll be looking at. You can say, okay, in triangle what? Which triangle? KDC. In triangle KDC. So your K2 is an exterior angle, right?
Yes.
And is equal to D2 plus angle C. Reason exterior angle of the triangle. What is your angle K2? Your K2 is called angle D, which is 44 plus 63. What do you get?
107.
Sorry?
107.
107 degrees. So, which means this angle here, K2 is 107 degrees.
Okay, to the exterior angle.
Of this triangle, look, because here's the triangle, right?
Even this one, right?
Yes, if you extend it, here's the exterior angle. Even if you look at this one here,
Okay.
if you extend it, there is it.
Yes.
It's just an exterior angle of both of them. You could have also said, look at this triangle your way.
Yes.
Yo,
Your
sure.
way.
And they won, and sure, they won. Then we're going to do example 2. Example 2. So they want us to show that these two angles are the same. Are you familiar with this angle and this angle?
Okay.
So where is C1 coming from? It's coming from this thing.
C1.
Yes, coming from this. And this angle here is coming from that. If you are lazy, you'll say these two are equal because congruent and equal chords obtains equal angles. That's an answer of a lazy person. Because what can we say? We can't say you are wrong because you're using an outcome. Because both of these things are subtended by equal chords. Are you with me?
Yes.
So equal chords equal angles, subtends equal angles. I'm not sure how the marking of that would go. Because it is correct.
But it is correct.
Yes. Is it, are you happy, Z? Okay. But now, because we're not lazy, we're going to look at this triangle ABC. Right? So in triangle ABC, what can we say is on triangle ABC?
What?
On triangle ABC, what can we say?
ABC or ABG?
ABD, sorry. Triangle ABD.
ABD.
Yes. What can you tell me about it? Yeah?
Okay, anything.
Yeah.
AB
AB
is called to AD.
is called AD. Why? This is given.
Okay.
That's what I've told you. Are you with me?
Yes.
So the diagram, everything in black is what you were given. So what else can you tell me from this?
From what I have.
Yeah, from this. If you're saying these two are equal, what else can you say?
Okay. Equal chords.
Look at this triangle. You said this is called this. What else can you tell me in a triangle of this nature?
Or B2
B2,
is equal to D2.
D2. Why?
Okay.
Angles,
Angles
opposite,
equal sides.
equal
Sides.
sides. Are you happy?
Yes.
Z, do you want to take it from here?
Oh, what the proof?
Yes?
Okay. So we said that angle. We said that angle B, right?
So
Angle
these
B.
two, we said these two are equal.
Okay.
Okay?
Then so angle C1
Angle C1
is equal to D2.
is equal to D2. Why?
Angles on the same segment.
These are angles in the same segment. Okay?
Then angle C2.
Sorry? So she said
C1. She said
C1
C1.
and D2. They're equal because they're angles in the same segment.
C1.
C1 and D2 are equal because These are angles in the same segment.
Oh, okay.
This is this. Same situation. Is this. Okay, see what we say?
Angle B2.
Angle
B2
B2
is equals to angle C2.
is called angle C2.
Angles in same segment.
Angles in same segment. So let's call it back.
Therefore,
Angle B2 is B2
B2 there.
or B2
Yeah.
is equal to C2
Yes.
because they are angles in the same
Segment.
segment. Are you following?
Yes.
Okay.
Therefore, angle C1 is equal to angle C2.
Therefore, angle C1 is equal to angle C2. Do you understand? Look, saying C1 and C2 are equal, right? So look what happened. You said C1 is equal to C2. Those are angles in the same segment. Are you following?
Yes.
Are you following?
Okay.
C1 is equal to D2.
D2.
These are angles in the same segment.
Okay.
And then you said D2 is equal to A1 because those are angles opposite equal sides. So your B1 is equal to C2. You're not following?
Yeah.
Okay, let me write it in the right order. Then. This order is a bit messed up. Okay. Let's start with the first one. Uzi, uthe B1, C1 is equal to?
And you're going to start with the B2 is equals to D2.
No, I'm not going to start with that because that's what you did previously. So I'm trying to make it more fluid now. B2, C2, which is C1, is equal to D2. Are you clear with that? Because these are angles in the same segment. They're both obtained by that. So angles in the same segment. Are you following?
Yes.
Then I'm going to say now D2 is equal to B2.
Okay.
So your D2 is equal to B2. Because those are angles. Opposite, equal sides. Are you happy now?
Yes.
Okay. Then now I'm going to go further and say now your B2 is the same as this one.
B2 is same.
B2 is called as C2 because these are angles in the same segment. They're both obtained by this.
Okay.
Your
B2.
B2 is equal to
C2.
C2. Reason? Angles in the same segment. Are you following?
Yes.
Look now. You said C1 was equal to D2. And said your D2 is the same as B2.
Okay.
Your B2 is the same as C2, which is these two are equal. Are you happy now?
Yes.
Are you happy, Z? So the other way of doing this without problems, just say maybe let this call this be X. I follow. Allow this to be X. Okay. Okay. Let's say maybe let's say here. Okay, at the end we'll just do it. Therefore, C1 is angle C1 is equal to angle C2. Are we clear now?
Yes.
Okay. So what I'm saying, when you start maybe, one of the angles that you want to start with, let's say, because start with C1, let's say let C1 and C1 be what? Be X. Which is what you have here.
Yes.
You have X there. Are you with me?
Yes.
And then you said the C1 is equal to
D2.
D2. And they will both be equal to what?
Yes.
X. So C1 equal to D2 should be equal to X. Are you following? And then you say, okay, angle D2 is equal to B2. And they're both what?
Yes.
They're both X. So B2 is equal to D2. B2 is equal to D2. What? B2 is equal to D2. These two are equal. They're both equal to X. Are you following now? And then at the very end, you will say, okay, your D2, your B2 is the same as C2. Your B2, where is B2? B2 that angle is the same as this one, which is equal to X. Yeah, one straightforward now. Because you can see that therefore these two are equal. Is it clear?
Yes.
So at the end, you say, okay, therefore these two are equal and they are both equal to what? To X. You're done here. That will give you all the marks. Because if you allow something to be X, easier to track it. Because look, but now this equal to this equal to this equal to this. Hey,
Yeah, confused. Are you?
This is called that. And then that's it. And I'm done with theorem 4. Now the next session we're doing theorem 5, cyclic quads to 6, then 7 to 9, and those will be tangents and other stuff. And I'm done here, and I hope this question or this session did make sense to you watching, as it did to all of us here. Thank you for watching. What do you want to tell them?
Don't forget to subscribe and like.
Don't forget to like and subscribe. Thank you. Cheers.